Hey y'all, so this is part 7 of the benchmark tutoring. So this is going to be physical versus chemical changes and how that relates to separating things. So let's refresh our memories, elements, compounds, and mixtures. If you look at elements, then that is just one sort of little atom here, so all the same type. We'll get into why this is a little different later in the year, so just look at this box here. So you have a bunch of circles, but they are all the same type, so there's nothing to separate there. In compounds, you have two different types of circles, which means two different types of atoms or two different types of elements that are literally bonded together. So they are linked. So you can't just pull them apart because they are part of the same thing. Versus in mixtures, see how I have like two elements in this big box, but they're not actually bonded together. So you can pull them apart without changing anything about what makes that specific type of circle. All right, so chemical changes, things that pop, fizz, color change, create a solid that came out of nowhere. What? So if you see any of that, it's a chemical change. So how we have this fire burning the wood, that is a chemical change. So burning wood is going to release carbon dioxide and water vapor, which you didn't have that before. So there was no carbon dioxide nor water vapor before. So this is something that happens at the molecular level. Whenever you have a chemical change, you have some substance, maybe two substances, and it changes and you have completely different things beginning and end. Like whenever you take elemental sodium and you drop it in water, the sodium and the water actually chemically react and the atoms rearrange. You can see that happening with that outpour of energy that was the fire. And then the sodium actually bonds with the oxygen and hydrogen in the water to make sodium hydroxide. In the beginning you had sodium, you had water. At the end you have sodium hydroxide. You didn't have that at the beginning. So if you have something at the end that you didn't have at the beginning, chemical change. So, how do you know if it's a chemical change? This is what I had just said. Was that stuff there before? If no, then you've changed the chemistry, and that's a chemical change. Okay, versus a physical change. So physical change is you've changed something, but it's still the same stuff. So is it the same chemistry as before? If it's yes, then it's just a physical change. You haven't actually changed what it is. So like if you have an ice cube and you melt it to liquid, that's a physical change. Notice you can go back and forth in your state changes. But how about this? You have a wine glass here, and then boom, you broke it. Did you actually change anything at the molecular level, like the chemical composition of glass? No, you didn't. So this is an example of, for example, an irreversible physical change. Notice that physical changes can be reversible and they can be irreversible. Like I can cut my hair and it's still hair, but I've changed it, so it's a physical change. I can't glue that hair back on and it comes back. So that's irreversible even though it's a physical change. All right. So this is your turn. You are going to identify each of the following as a chemical or physical change. Remember, is it the same stuff as you started with, or is it different? If it's the same, it's physical. If it's different, it's chemical. I don't have any fun way to remember that, but if it's the same, it's physical. If it's different, it's chemical. This has absolutely nothing to do with reversibility of a reaction. So don't think about that. Just think about the chemistry of the stuff you started, the molecular makeup. Does it change or does it not change? If it changes, it's chemical. If it's the same, it's physical. Okay, so freeze your video and we'll be back in a minute to discuss. So press play only when you're done answering these to the best of your ability. Okay, so you should have gone through this. So let's talk about putting air in a balloon. You had a balloon and air at the beginning, and you have balloon and air at the end. So this is a physical change. How about digesting food? You ate a hamburger. Does it come out as a hamburger? Well, no. You're pulling in all those nutrients, you're breaking it apart, and then literally sucking out different nutrients at different parts of your intestines. So that's going to be a chemical change. You are breaking those bonds, right? If you eat a steak, You have to pull apart all the different proteins that you need within that steak, and that's changing the molecular structure. Salt dissolving in water. This one is a difficult one for entry chemistry students to think about, but you have salt and water at the beginning, you have salt and water at the end. You can also think about to separate these would just be a physical change. You would boil off the water, and that's just a state change, and then you're left with salt. So you don't do anything to the chemistry. They are literally just hanging out together. It's just you can't really see salt when it's in the water, but it's still salt and water. So salt and water together, salt and water. So it's a physical change. There's no change to the molecular composition of these things. How about filtering gold out of water? So if you think there's gold in an area, you have the sifters and you kind of move it around and the gold comes up and everything else goes away. That was gold and water, and it ends as gold and water. So it's a physical change. Lighting a candle. So when you have that wick on it and you light it, the wick is burning, and whenever you burn anything, that's going to be a chemical change. You're actually changing the chemistry. You had wick at the beginning, you don't have it at the end. Baking a cake, anytime you cook something, that's going to be a chemical change. All right, so that is it for the video. Please be sure you talk to your teacher if you have any questions about this, and happy studying. It's almost time to retake that benchmark.